All right, let's dive into design patterns today, specifically the builder pattern. Now, I know design patterns. It doesn't exactly scream excitement, right?
Uh-huh. Yeah, I get that.
But trust me on this one. The builder pattern, this is like, it's like finding a secret weapon for writing better code.
I like that.
It helps you create these complex objects, but in a way that keeps your code, neat and tidy, easy to work with, easy to change later on. It's like, think of it like building with Legos.
Oh, I like that analogy.
You've got all these different pieces. In the builder pattern, it's like having those instruction booklets.
Yeah, that makes
So
sense.
you can put together, a spaceship or a castle or whatever you can dream up.
Mm-hmm.
But in this case, instead of plastic bricks, we're talking about lines of code.
Right, so we're building software.
Exactly.
Right.
And to guide us through this, we've got two sources. One's a bit more on the technical side from refactoring.guru. The other's a really fun video by Derek Banas. So let's see what we can learn. All right, so jumping in, refactoring. Guru, they use this analogy of building a house.
Yeah, it's a really good one, I think, because it really helps you understand the problem that the builder pattern, it's trying to solve.
So instead of like trying to cram every single detail of the house,
Right.
like the plumbing, the electrical wiring,
Oh, that's the...
all into one massive, blueprint,
Exactly.
which would be a nightmare, right?
Oh, absolutely. Can you imagine trying to, read that blueprint? It would be impossible.
And then imagine trying to code that. You'd have this constructor
Right.
with like a million
For every
parameters,
little thing, yeah.
like, the color of the doorknob,
Huh.
the type of wood for the floorboards.
And not every house needs all of those things. It doesn't make sense.
It'd be like baking a cake. But the recipe includes like every possible frosting,
Oh, I see.
every filling, every sprinkle, all at once.
You'd never get the cake baked. It would be too much.
Exactly. You just get lost in the detail.
And, the problem goes beyond just visual clutter in the code. The more parameters you have, the harder it is to understand what the code's actually doing.
Makes sense.
And it makes it really difficult to change things later on.
Yeah, if you wanted to add, I don't know,
Yeah.
like a skylight,
Right. Exactly.
you'd have to go back and change a whole bunch of code
Yeah. Potentially a lot of code.
just for that one little feature.
It creates a ripple effect,
And I remember reading about this thing called telescoping constructors.
Oh, yeah. Telescoping constructors, that's kind of like a Band-Aid solution for this problem.
So it's basically like having multiple constructors,
Right.
each one with a different set of parameters.
Yeah. So you might have one constructor for a really basic house, just the bare minimum.
Okay.
And then another one for a house with a garage.
Okay.
And then another one with a garage and a fireplace.
Oh, wow. Okay.
And so on and so on. It gets really messy really fast.
Yeah, that sounds like a recipe for disaster.
Yeah.
So where does the builder pattern come in?
Okay, so the builder pattern basically says, let's take this whole process of building the object and let's separate it from the actual object itself.
Okay.
So instead of having everything crammed into the constructor,
Right.
we create this separate builder object
Okay.
that handles, all the steps of putting the house together.
It's like having a dedicated construction crew.
Exactly. They know how to build a house, and they do it step by step.
So instead of that one giant blueprint, we have these more manageable instructions.
Yeah, like individual blueprints
Yeah.
for each stage of the process.
I like that.
And this makes the code so much easier to work with.
All right, now I have to bring up Derek Bornas's video because his analogy is just, it's too good.
Oh, yeah, the alien, the robot, and the engineer.
Exactly. So he's got this alien. Who wants a robot? Right. But the alien, they don't need to know. Like all the details of how the robot is
Oh, the
built.
nuts and bolts, yeah.
They just want the finished product.
Exactly. They just want their robot.
It's like going to a car dealership. You know what kind of car you want.
Right.
But you don't need to know how the engine works.
All the technical details, yeah.
Exactly. You just want to drive it.
So in this analogy, the engineer is like the director. They're the ones who orchestrate the building process. They use the builder, which is like the blueprint,
Yeah, the instructions for building the robot.
to create the robot according to the alien's specifications.
And what's great is Derek Banas, he gives this robot all these really memorable features.
Oh, yeah.
Like a tin head, a tin torso,
I love that.
blowtorch arms, roller skates.
A robot with roller skates, come on.
It's awesome.
That's amazing. But it actually helps you understand how each step in the builder pattern corresponds to a specific part of the robot.
Right. Each feature is like a separate step.
Yeah.
in the construction process.
So it's not just some abstract concept. It's like, okay, step one, build the tin head.
Exactly. It makes it much more concrete. I love that. And this whole modular approach, it has some big implications for code.
Oh, yeah, absolutely. It makes it much easier to maintain and to change things later on.
Which is what we'll dive into next.
Looking forward to it.
Yeah.
Yeah, so maintainability. Like imagine you're working on this big project and you need to add, I don't know, let's say laser eyes to your robot.
Ooh, laser eyes. That's a cool upgrade.
Right. But if you're using that massive constructor we talked about,
Yeah.
adding laser eyes, that could be a real pain. You'd have to add a new parameter and then, change a bunch of other code. It would be a mess.
Yeah, but with the builder pattern.
With builder pattern, it's much simpler. You just add a new method to your robot builder. Let's call it add laser eyes.
Okay.
And then you just implement that method in your concrete builder, like the old robot builder.
Got it.
And boom, you've got laser eyes.
And no headaches.
Exactly, no headaches. You haven't messed up the rest of your code.
It's like adding an accessory to your car. You want a sunroof. You don't have to like redesign the whole car.
Right, you just bolt it on.
Exactly.
And that's the beauty of modularity.
Yeah, I'm starting to see that.
Each step is it's kind of self-contained. So you can change one thing without breaking everything else.
And this modularity, it also gives you a lot of flexibility, right?
Oh, absolutely. You can create like different types of robots using different concrete builders.
So like you could have a ninja robot builder.
Yeah, a ninja robot builder.
And builds a stealthy robot.
Exactly.
And then maybe a super robot builder.
Right, for a robot with super strength.
I like it.
And they all follow the same basic blueprint.
Which is defined by the robot builder interface.
That's right.
So it's like they all speak the same language.
Yeah, they all know how to build a robot, but they each have their own style.
This is where interfaces are really powerful, huh?
Oh yeah, interfaces are key here. They provide that contract.
Okay.
So the director knows that any builder it works with, it's going to have those core methods.
So it's like having a universal remote control that works with different TVs.
No, I like that.
The buttons might be in different places.
Right.
But they all do the same basic things.
Exactly. You can still change the channel. You can still adjust the volume.
All right. So speaking of the director,
yes,
let's talk about their role a bit more. We mentioned earlier that the engineer in Derek Banis's video was like the director.
Right. They were the ones who kind of oversaw the whole building process.
Using the builder, like the blueprint, to create the robot.
According to the aliens' specifications.
So the director, they're not actually building the object themselves.
No, they're more like a project manager.
Okay, got it.
They define the steps and the order in which those steps need to be done.
So they're like a chef with a recipe?
Yeah, a chef who's directing the kitchen staff.
But you also mentioned that the director is optional.
Right.
So if they're not actually doing the building, what's the point of having them?
Good question. So the director, they bring a couple of key advantages.
Okay.
First, they ensure that the object is built in a specific way.
So they add a layer of consistency?
Yeah, consistency and control.
Yeah.
Like if you have a complex object with a lot of steps,
Right.
the director makes sure that those steps are always done the right order.
Okay.
So you don't end up with a robot with its head on backwards.
That would be a problem.
Right.
So the director is like a conductor leading an orchestra.
I like that.
They make sure everyone's playing the right notes
At the right time.
to create a beautiful symphony.
Exactly. And the second advantage of a director is that they let you create different recipes for building the same object.
Recipes, huh?
Yeah.
Now you're talking my language.
So, sticking with our robot analogy,
Yeah.
you could have a basic robot director
Okay.
that creates a standard robot.
Using the old robot builder.
Right. But then you could have an advanced robot director that
Right.
uses the same old robot builder, but adds extra steps to create a more sophisticated robot.
So you can have multiple directors,
Yeah,
each using the same builder,
exactly.
but they orchestrate the building process differently.
Right, to produce different results.
It's like having different sets of instructions
Makes
for building different things with Legos.
Yeah, you can build a car or a spaceship using the same set of bricks.
And the director is like the instruction booklet.
Exactly.
This is all starting to make a lot of sense.
Glad to hear.
So we've got the builder,
Right.
we've got the director, but what about the final product itself?
Ah, yes, the product. That's the culmination of all our hard work.
The robot with laser eyes.
Exactly. The fully constructed object.
So the product, it's like the end goal.
Right.
The thing we set out to create.
In a clean and manageable way.
And we can have different versions of the same product.
Yeah, absolutely. Like, we can have a standard robot.
Yeah.
A ninja robot, a super robot.
All built using the same builder pattern.
Exactly. It's all about that separation of concerns.
Right. The builder handles the construction. The director, they're like the project manager.
Mm-hmm.
And the product is the end result.
It's a beautiful system.
Yeah, it really is.
Now, there's one more layer of complexity that we can add to the builder pattern.
Oh, okay. I'm intrigued.
It's a way to introduce variations.
Yeah.
Within a single builder. We've been talking about different types of robots, using different concrete builders.
Right.
But what if we want to have, like, variations within a single builder?
Oh, okay.
So instead of having a ninja robot builder and a super robot builder, we could have just one robot builder that can handle, all sorts of different robots.
Got it.
We could add methods to our robot builder interface.
Like what kind of methods?
Like add laser eyes.
Okay, yeah.
Or add rocket boots.
Oh.
Maybe even add stealth mode.
So each method is like adding an optional feature.
Exactly. It's like building a custom robot.
I like that. It's like those video games where you can customize your character.
Yes, exactly like that.
You can choose their hair, their clothes, their weapons.
And you can do all that without having to, like, create a whole new character.
Right. It's all within the same character creation system.
And that's what we're doing here with the builder pattern. We're giving the client code the flexibility to create all these different variations.
And it keeps the code nice and organized.
Yeah, because we're not creating, like, a million different builders.
Right. Just one builder with a lot of options.
And that makes it much easier to maintain the code.
It's like having a toolbox with all the tools you need to build anything you want.
I like that analogy. And you can add new tools to the toolbox.
Without having to redesign the whole thing.
Exactly. It's
Okay.
very flexible.
So we've been talking about robots, but this idea of variations within the builder, it can be applied to, like, any kind of object, right?
Oh, absolutely. Think about building a user interface
Okay.
with lots of customizable elements.
Like a website builder?
Exactly. You could have different templates,
Uh-huh.
different layouts, fonts, colors,
So many options.
and the builder pattern with variations that lets you handle all that complexity in a really elegant way.
So it's not just about robots, it's about creating any kind of complex object that has a lot of customizable options.
Exactly. And it keeps your code, clean and maintainable.
It's like a superpower for handling complexity.
I would agree with that.
Well, this has been a fascinating deep dive into the builder pattern.
I've enjoyed it.
I feel like I've learned so much.
Me too.
And I think our listeners will too.
I hope so.
We've covered a lot of ground.
From basic concepts to more advanced variations.
And we've seen how the builder pattern, it can help us write better code.
Code that is easier to understand, easier to maintain,
Yeah.
and easier to change.
And that's really what it's all about, right?
It is. It's about writing good software.
So if you're out there listening
Hey,
and you haven't tried the builder pattern yet,
I encourage you to give it a shot.
it might just change the way you think about coding.
It might.
And until next time, happy building.